final part of this course is devoted to central toricity. The ESA design offers the advanced option to incorporate a toric optical zone. To correct astigmatism, a lens with peripheral toricity, a peritoric lens, is selected. Under normal circumstances, central corneal astigmatism is corrected automatically by the tear reservoir beneath the lens spherical center. However, in rare instances, a residual central astigmatism remains even with a perfectly fitted peritoric lens. Notably, this residual astigmatism may not share the same axis as the original astigmatism. Its orientation is determined by the specific rotational position in which the lens stabilizes on the eye. In these situations, central toricity can be added to the design, provided specific clinical criteria are met. A lens featuring both peripheral and central toricity is referred to as a dual toric lens. Predicting the need for a dual toric lens, or calculating its precise parameters, is impossible during the initial consultation. Its necessity only becomes clear after the fitting process is complete. To confirm persistent residual astigmatism, the patient must wear an appropriately fitted peritoric lens for an additional 10 to 15 days following the initial 1-month fitting period. Only after this stabilization period can such residual astigmatism be accurately measured. Furthermore, a dual toric design requires a minimum of 3/4 of a diopter of peripheral toricity to ensure the lens remains rotationally stable. Without this anchor, the central correction would drift and blur the patient's vision. A lens is considered appropriately fitted when it meets the following 4 criteria. 1. Correct diameter. This is very important. 2. Optimal sagittal depth. The lens exhibits an appropriate edge lift along the flat meridian, typically with a width of approximately 0.4 mm. 3. Correct peripheral toricity. There is a consistent edge lift of approximately 0.4 mm and a uniform alignment zone around the entire circumference. In this configuration, the central bearing zone appears elliptical, while the tear reservoir zone width varies, wider along the steep meridian and narrower along the flat meridian. 4. Accurate target power. With a lens on the eye, the over-refraction results in plano or matches the specific refractive target planned by the practitioner. If persistent, insufficient visual acuity is detected after 10 to 15 days of consistent wear, you must confirm that the blur is specifically caused by residual astigmatism. This is verified by performing a manifest over-refraction. The diagnosis is confirmed only if the patient experiences a measurable improvement in clarity, adding several optotypes or full lines on the Snellen chart when a cylindrical trial lens is introduced. It is essential to determine both the axis and the optical power of this residual cylinder. In this clinical scenario, an autorefractometer cannot be used. The internal algorithms for these devices are not designed for altered corneal shapes. Consequently, the device is highly likely to produce inaccurate or false results, making manual over-refraction the only reliable method. Furthermore, it is essential to verify whether the patient exhibits astigmatic refraction while wearing the lens. If a residual cylinder is detected during over-refraction, it indicates the presence of internal, lenticular, astigmatism. Typically, this cannot be corrected, with one specific exception that we will discuss later. Next, determine the exact orientation of the stabilized peritoric lens on the eye. This is achieved by identifying the principal axes of the elliptical central bearing zone. The shorter axis of the ellipse corresponds to the steep meridian, while the longer axis identifies the flat meridian. Finally, you must verify that the axis of the patient's residual myopic astigmatism aligns, or nearly aligns, with the steep meridian of the lens. If all the clinical conditions described are met, you may proceed with ordering a dual toric lens. In this clinical example, the patient was fitted with a peritoric lens featuring the following parameters: overall diameter of 10.8 mm, a nominal K of 8.4 mm, a target power of -3 diopters, and a peripheral toricity of -2 diopters. Upon follow-up, the over-refraction was measured at plus 3/4 of a diopter, which is the expected result, indicating that no internal astigmatism is present. The clinical situation is stable by night 7, following the initial 1-month fitting period, and remains unchanged through to night 15. Visual acuity is 0.9, and cylinder of -1 diopter brings it to 1.1. Per the Tabo system, myopic meridian is located at 130 degrees. Since there has been no improvement over the final week, we conclude that the refraction has fully stabilized, leaving a residual astigmatism of 1 diopter that requires a specific correction. The axis of the lens steep meridian coincides perfectly with the axis of the patient's myopic component, 130 degrees. Because these axes are aligned, and the lens is rotationally stable, we can now proceed with the final order. We need to order a lens incorporating a central toricity of -1 diopter to match the patient's residual clinical refraction. All other parameters should remain unchanged. Overall diameter is 10.8 mm. Nominal K is 8.4 mm. Target power is -3 diopters. Peripheral toricity is -2 diopters, and central toricity is -1 diopter. With the final lens in use, the patient's visual acuity increased to 1.2, or 24/20. The residual refractive astigmatism has now disappeared. The axes of central and peripheral toricity are always mutually perpendicular. This is necessary because the additional corrective effect in the central zone must be exerted along the steep meridian, where the initial flattening was insufficient. To achieve this, the central zone of the lens along this specific meridian must become flatter to enhance the refractive change. Consequently, the flat meridian of the central zone is oriented perpendicular to the flat meridian of the peripheral zone, thereby coinciding with the peripheral steep meridian. The clinical sequence for successfully fitting dual toric lens is summarized in these 6 essential steps. 1. Baseline fit verification. Confirm that the peritoric lens is correctly fitted and verify there is no astigmatism present with the lens on the eye. 2. Stability period. Ensure that stable residual astigmatism persists for at least 10 to 15 days after the initial fitting phase, confirming the cornea has stabilized. 3. Cylindrical trial lens. Verify that correcting this residual error with the cylindrical trial frame lens significantly improves visual acuity. Precisely determine its optical power and axis. 4. Axis synchronization. Ensure that the myopic component of the residual astigmatism coincides with the steep meridian of the stabilized peritoric lens on the eye. 5. Ordering. Order a new lens incorporating central toricity. The magnitude of this central correction must match the exact optical power determined by your trial lens over refraction in step 3. 6. Verifying clinical impact. After several nights of wear, visual acuity should improve as residual refractive astigmatism is neutralized or significantly reduced. As previously noted, dual toric lenses can be utilized to correct internal astigmatism, but this is clinically viable in only one specific scenario. To achieve this, 2 critical conditions must be met simultaneously. 1. Toric periphery. The cornea must possess sufficient peripheral toricity, 3/4 of a diopter, and the patient must be fitted with a correctly sized and aligned peritoric lens. 2. Optical alignment. The myopic meridian of internal astigmatism must coincide or nearly coincide with the steep meridian of the stabilized peritoric lens on the eye. This ensures that the physical stabilization of the lens aligns with the internal refractive error. In this case, the protocol remains largely the same. However, if during the peritoric fitting we observe that the axes of internal astigmatism differ significantly from the axes of corneal astigmatism, that is, by more than 20 degrees, and the physical orientation of the lens on the eye confirms this discrepancy, then adding central toricity is unlikely to compensate for the internal error. Unfortunately, clinical experience shows that the axes of internal and corneal astigmatism rarely coincide. Consequently, while the clinical necessity for a dual toric lens arises only in specific rare cases, having the expertise to prescribe it significantly expands a practitioner's arsenal. This concludes our training course. We hope that the simplicity of the ESA lens fitting algorithm, the high efficiency and versatility of this unique design, and the availability of user-friendly virtual platforms for lens selection will attract your attention and enhance your clinical practice. We encourage you to experience the results firsthand by fitting ESA lenses to several of your patients. Our team is fully prepared to provide the clinical support and guidance you need to ensure success. Best of all, no initial investment is required.